All right, guys, so today we are going to go over our last lesson in the chapter, which is qualitative graphs, so 4.9. We're going to talk about a lot of different types of graphs, such as acceleration, deceleration, stationary, and constant. I'm going to go ahead and draw out what each one means. So let's go ahead and start off with acceleration graphs. I'm going to go ahead and highlight my different types of graphs, the topics in pink, just so that we can keep things separated and keep it organized. So when we're talking about acceleration graphs, we're talking about something that starts off slow and then increases speed and eventually goes fast. So let's say we had a graph that looks like this. And as a matter of fact, we're going to have two different types. And for our x values, we're always talking about time. And then for our y values, we're going to be talking about distance. So I'm trying to write this sideways. Okay. So when we have our acceleration graphs, we're not going to have a straight line like we're usually used to. We're going to have something that does this, kind of like a roller coaster, where in our roller coaster, we're going to start off slow, and then we're going to increase the speed faster. An acceleration graph can also go this way. Where we start off slow, and then we increase the speed faster. And this one makes more sense compared to a roller coaster because we always start slow before we get our big drop here. But again, with acceleration, the big idea is that it's going to start off slow and then it's going to go fast. Okay, now we're going to talk about deceleration graphs. And I'm going to go ahead and draw a similar charts or similar graphs. We're going to have two of them. And again, our x values are going to be time, because we're measuring something, some sort of value. And then our y value is going to be distance. And then you can kind of already guess what our deceleration graphs are going to look like. Our first one is going to look like this. And our second one is going to look like this. And in this case, we're going to have the opposite of an acceleration graph. We're going to start fast and then we're going to go slow. Again, we're going to go fast and then go slow. Another type of graph that we're going to look at is something called a stationary graph. And again, I'm going to highlight my title to keep things organized. Again, we have a type of graph where our x values is measuring time and our y value is measuring distance. But our actual stationary graph is going to be linear, and it's going to look like this. And after we go over these notes, we're going to go ahead and see some more problems where we're going to put these types of graphs into some kind of real life example. So it'll make a little bit more sense. But all we need to know for a stationary graph is that this is not moving, because it's just a straight line. There's no acceleration, there's no deceleration, it's just straight. And last but not least, we have something called a constant speed. Again, let me go ahead and highlight. And with constant speed, I'm going to go ahead and draw out my two different types of graphs. You know that our x value is time. You know that our y value is distance. Again, we know that our x value is time. We know that our y value is distance. Just going to put a d to shorten it. And so when we have a constant speed, we have something that looks like this. Or we have something that looks like this. So we do have a linear function, something that we're used to seeing. But again, we're talking about a constant speed. And now we're going to go ahead and talk about the different types of problems that we can apply to these different types of qualitative graphs and give it some kind of meaning instead of just seeing some graphs with some different lines on it.